Okay, so we've got the number of passengers who fail to turn up for the flights each month. And actually, I read a very interesting piece recently that airline companies tend to overbook planes for this very reason. So if there's 100 tickets available on a plane, they will sell 105 because they know statistically 5 people won't show up, which is why in the movies you see people turn up and, or maybe it's happened to you, you turn up and the flight's overbooked. You think, well, surely you know how many seats there are. But apparently they do this because they know some people won't turn up. And yeah, if then everyone does turn up, they just take the hit and put someone in a hotel or something like that. But yeah, fun factoid. So this is a great question. Your median, mean, all that kind of stuff. Doing a bit of statistics and doing a box plot. So let's do this then. First thing you need to do is get all your numbers into order, and this can be the bit that actually is the hardest. Okay, so just take your time. Okay, score them out as you go. That's 14, 17. I see a 20. Another 20. But yeah, really just take your time. 23. If you make a mistake, it's fine because you can just rewrite them. 25. There's a 27. 29. 32. 38. 43. And a 49. I note that I wrote these underneath those numbers, so I now know I've definitely not missed a number, and I scored them as I went, and I can just look back and go, yep, that's in line, I've not missed anything, okay. So that's your first thing to do. Now the median and the quartiles are just splitting this data in half and half again. Okay, so we've got 10 bits of data here, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it's 12. 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 12. So if I split 12 in half, I'm going to have 6 and 6 on each side. Okay, so I'm going to split it right down here. 6 numbers here, 6 numbers here. That is your median, right in the middle. So between 25 and 27 is the number 26. So I know my median is 26. Right? And the quartiles are where you say, okay, I'm going to look at these 2 bits of data now on their own. I'm going to look at this set of data, and I'm going to look at this set of data on their own, ignoring the other side, ignoring the median. And I'm going to split that in 2. So if I split that in 2, I'm going to get a number here, and I'm going to get a number here. So that's going to be my Q3, my upper quartile, and that's my Q1, my lower quartile. And if you look, this does make sense, because I've got 3 bits of data here, 3, 3, 3. I've split it into quartiles. So if you look at it, you should see it makes sense. Okay. What number's between 20 and 20? Well, that one is just 20, isn't it? That number would be 20. And what number's between 32 and 38? Well, it's a wee bit harder, that one. And the sum you actually do is you add them together, and then you divide it by 2. So that's going to give me 7, so that's going to be 35. Okay, so don't worry if you get any decimals and stuff. You just add them together and divide it by 2, and that's 35. Okay. So you're going to get your 2 marks for that. Fantastic. And now you're going to get marks for drawing your box plot. So the box plot is where we have to show our lowest value. So there's our 14, and our highest value at 49. So just watch out for there's one box I go, but just watch out for the units, okay? And you also want to, I maybe do them full height actually. Yeah, and then you want to show in your Q1, median, and Q3. So I'm going to mark on 20. I'm going to mark on 35. And I'm going to mark on 26, which is in here. So it's a really interesting bit of analysis, this. You split your data, like you said, into quarters, and all that means is every little bit of the drawing represents 1/4 of your data. So obviously you would use a ruler, okay? And I think you have to mark on constructible. I'm trying to check. Yeah, I actually just think if you draw like that, you're okay. I don't you have to mark on. Yeah, that's good. This is saying that 1/4 of your data rests in here, 1/4's in here, 1/4's in here, another 1/4's in here. So, a nice tight bit of data, where it's a small box and there's not big ends, shows you're very consistent. So imagine you're playing football, it's like you're constantly hitting the same bit of the goal. You're always, right in where you're aiming. But if you've got a big box, if you've got a big line here, you're saying you're kind of all over the place. You're missing, you're not getting at the goal, whatever. So yeah, when I'm looking at data, I do this, and if you've got a nice tight box, you're saying now that you've got 50% of your data in here, 25 and 25. So you want most of your data around, where you're after, your data all over the shop, Anyway, so that's you constructed it. a good 5-mark question this. And the interquartile range, that's just the distance. That is just this. Okay, the interquartile range is effectively the distance from the mean to the quartiles. Okay, so your interquartile range is this distance here. Semi-interquartile range is half of that. Okay, which is almost like this distance. It's almost that, but not quite. It's like the average of these two distances. Okay, but it's half of that. Okay, so your interquartile range is just going to be 35 take away 20. So 35 take away 20, which is 50. So great question to get, really good question because it's nice and visual. You know, you can see what's going on. You're effectively just halving your data and halving it again. And your interquartile range is just range. You know, range is distance. Yeah, your range of data would be from the max taking away the min. Your interquartile range is the upper quartile taking away the lower quartile. Yeah, and the semi-interquartile range is half of this number. So it's a great question to get 5 marks. And you know, there's not a lot doing in that one, but it's technical, and that's why you get a few more marks than some of the other questions. So I'd work on this. I'd really get your and make sure you know your stats well because it's good marks. And then your final mark is in 2016, the interquartile range for the number of passengers was 17. Make one valid comment comparing the number of passengers who failed to turn up. So the interquartile range in, what was this one for? In 2017 is 15. So the interquartile range in 2017 was 15, and the interquartile range for 2016 was 17. So what's happened over time? Well, over time, this has gone down, hasn't it? Yeah, so the interquartile range has gone down, which means this box has gotten smaller. So if it's gotten smaller, the results have become more consistent. So I'd be saying that the results in 2017, the results are more consistent than 2016. Right? So yeah, they've said the other way around. They said in 2016 the number of passengers who turned up was more varied, but you know, so in 2017 the results were more consistent. So you could actually beef it out a bit and just say the number of passengers who failed to turn up for the flights was more more consistent. You know, but you link it into the question, and the point is that if you've got a small interquartile range, you've got a more consistent set of results. Yeah. So this one is saying that you've got less consistent results. So you're saying that the numbers were more varied. You know, some days it would have been 10, some days it was 55, whatever. In this one, the numbers are slightly less varied. Okay, so the number of passengers who turned up was less varied. You know, it was more consistent. Okay, so maybe they were, you know, round about 25 more often or something. Do you know what I mean? So just watch out for that. Okay, and if you're looking at comparing your averages, make sure you use the phrase on average. You can use it for this, but make sure you say on average when you're comparing your medians or your means. Okay. So yeah, I'll just write that for you. So in 2017, the passenger numbers or passenger numbers who failed to turn up was more consistent than 2016. More consistent, smaller interquartile range, more consistent. Okay, hope that was helpful.